It is 2 hours UTC, and once again, we are here. At least I am here. I hate it. A lot of YouTubers and podcasters and things, they uh, they they say things like, uh, "We are here now, and we are doing this, and we are doing that," when it's you know one one person. So yeah, this is just me doing this. So I am here. Hope everybody's doing well for another episode live of Astronomy Daily Live. This is where we get together every single day, gather together in a little circle of friends, and share a common passion, which is the science of astronomy. And I'm just getting myself set up here. That's why I'm a little distracted. Gonna pop my chat out over here whenever it decides to load, taking its time. I'm also going to check my smartphone, make sure that I am running live. There's the chat. Looks like I'm live. Hey, hope everybody's doing well today. You know what? You know what? It is clear. It is getting dark, and it's going to be probably a pretty decent night. The moon isn't around, and you know what? I'm not going to be doing a session tonight. Had to make an executive decision, and I decided that I was just going to skip a perfect night. Um, you know, one can skip over perfection from time to time, especially if there's anticipation. Pretty good chances that there are going to be more perfect nights, and plus, I haven't looked at really a lot of the data that I have from 2 sessions ago, much less my previous section a few nights ago. So I don't feel too bad. The only thing that probably would have pushed me to get out there tonight was if I had been a little bit more prepared and uh, looked into a like an eclipsing binary star system that I could observe um, doing its thing at a reasonable time tonight. But didn't do my homework fast enough. And so, yeah, I really didn't get a chance to look too hard at that. That's the only thing I think that would have uh, prompted me uh, to be observing tonight. So I've got a perfect night out there tonight, and I'm not going to be doing a thing. So yeah, no worries, no worries. I've got lots and lots of data, and as I said, I think there's going to be um, quite a few nights like this, especially this time of year. This time of year until the monsoons start in July um, is probably the most number of clear nights. So it's a little bit more rare to have a clear night and so close to the new moon, but I'm not really even too worried about that at this point. I don't really care if the moon is up or not. So that's sort of an artificial thing where it's like, oh, I don't have any moon. I've got a pitch black sky. I should be out there, but it's like, yeah, I've got lots of data that I still have to go through, and the preliminary look at it. Yeah, I, you know, data is funny, and I've got to take a little harder look at what I've got and see what's going on with that, because the first look mm, isn't isn't as nice as I expected it to be. But there are some funny. I know I'm being very um, um, ambiguous, but there's some funny stuff in the data that I noticed that needs to be dealt with or at least understood. So I need to be looking at that all a little bit harder. The the thing actually on the top of my head these days is a music festival that me and my musical partner are going to be playing at next weekend. Uh, and so actually my focus has been on music and not so much on astronomical things, although astronomy is always wiggling around in my head. But today was working on some composition. I think I've got a pretty interesting sound. Um, I'm going to play at least one solo and possibly two. So I have to have two in my pocket, and now I basically do. So I've got that. I've got to practice the songs that we're going to perform. We're going to rehearse those on Monday, and then play them for the crowd on the main stage at a music festival in Bisbee uh, this weekend. It actually starts on Thursday. We play on uh, Saturday late afternoon. I think we're supposed to go on at 5:30. So we're on from 5:30 to 6:45. So that's a pretty good prime time. It's not the best, but yeah, it'll be interesting. It'll be interesting. I like playing for crowds. That may be the largest crowd that I'll have ever played in front of in quite a while. Quite a while. So yeah, I play keyboard, mainly keyboard, little bit of guitar, although I've still got a long way to go in terms of being, relatively proficient on the guitar. My keyboard playing is pretty good. Um, I will never claim to be, an expert or a pro or anything else. Those are words for others to make, not for me. So I'm extremely critical of my work, and uh, therefore, um, what I'm doing is mostly always pretty garbagey. Um, but others say, that they like my sound and they like how I play, and the person I'm working with, my musical partner, is very good. He plays native flute, and so I just accompany him on that. Excuse me. Now I've got some coffee tonight. I think this is going to be a short podcast, but we'll see. We'll see how it goes. Hope everybody's doing well. This is just a fun, casual get together of friends every single day. Now you can come in anytime you want, right? If you want to come in every single day, very cool. If you want to come in every other day, every week, every month, whatever it is, I'm here. 2 hours UTC, usually running I want to say between 30 minutes and 75 minutes, something like that. Um, Sometimes it goes a little short, sometimes it goes a little bit long. Um, I think the length of the live stream probably isn't as important as being here every single day at the same time. I think that's probably most important, and having some relatively decent content. You know, as I said, this is very very casual. This is very very fun. So it's not as if I'm up here, you know, giving a lesson or trying to teach things, um, or anything else. I'm just having a conversation with some friends about a common passion and sharing the passion, spreading the passion around. I think being an astronomer, uh, is a interesting and relatively rare perspective. There aren't really a lot of astronomers in the world, relatively speaking. There might be, I don't know, maybe a couple 100,000, maybe, I don't know. There's really not too many. And when you compare that to, you know, the number of football fans, or the number of baseball fans, or the number of Republicans, or the number of Democrats, or the number of socialists, um, those numbers don't really, you know, the astronomers are a very, very, very small portion of the population of the world. But I do believe that we hold a very interesting and, as I said, pretty rare perspective on things, because we have this ability to sort of, you know, get some of the universe packed into our head. We sort of we can we can handle, um, sort of the enormity of things to a certain extent, and to be able to hold at least a portion of the universe in your head, I think creates an interesting perspective that not everybody should have, can have, but if enough of us do, maybe we'll realize how awesome everything is, how awesome we are, and how absolutely ridiculous some of the things that we do are, like fighting, and uh, you know, uh, feeling as though there isn't enough to go around. It's absolutely ridiculous. It's absolutely ridiculous. We've that perspectives have to change, and part of this podcast is to sort of spread that message, is that there is enough. There's more than enough. We don't have to fight over resources. Um, I think humans will always fight, because somebody is always insulting somebody else, or putting them down, or worse. So I think humans will always fight, but the big fights over, you know, do we have enough, and how do we get what they have, and all that. That's going to go away, because I mean, as we expand, get off of this planet, go into this planet. Okay, we have literally only scratched the surface of this planet. Um, uh, so we've got to go out, right? We've got to go out, and we have to go in. And I think if we cover all of that, we're going to be astonished as to how much stuff there is and how much, new stuff that we just don't know anything about at all. We just have to, expand a little bit, um, get different perspectives on things. So one of the cool things that a lot of people don't realize is how much activity is going on in the sky, in the night sky. You know, you a typical person looks up at the sky from time to time, sees stars, sees the moon, pretty much pretty much the same. Things don't really seem to change that much. You really don't see a lot of things happening. And well, I argue, at least, that one of the reasons why we don't necessarily see things happening is that we're just not looking. We're not looking carefully enough. We're not looking, uh, you know, uh, at a large enough area. We're not looking uh, on different time scales, all of that. Now, we're starting to get into that mode, right? We're talking about big surveys and um, you know telescopes like every scope that that can that can see huge portions of the sky like every 2 minutes or so. So it turns out that there's a lot of shit going on. Um, you know, as much is going on out in space as there is going here on Earth, right? I mean, things are happening all the time, and it just depends on your scale, your um, perception in order to see those kinds of things. And one of the cool things that is always happening is what's called an asteroidal occultation. And asteroidal occultations is when an asteroid passes. Oh, I'm going to turn my fan on. When an asteroid passes in front of a star, so you're standing on the surface of the Earth. Okay. Now imagine this. Imagine the geometry here. Okay. You're standing on the surface of the Earth and you're looking at a star, right? At a star, which is basically a point source way out there, right? Stars are so far away that unless you have a really, 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 really huge telescope and some fancy hardware and some fancy software, you cannot see the surface of any star at all. Okay, it falls onto, on your camera, it falls onto a single pixel, right? You can't see a thing, right? Usually because of atmospheric distortions, maybe things out of focus a little bit, it falls on several pixels. Also, the optics of the telescope um, distort these point sources. So it's basically a point source, right? Asteroids, depending on how big they are and how far away they are from the observer, right? Which depends on the motion of the asteroid and the motion of the observer themselves. That is going to make for an apparent size of this asteroid. And the apparent size of any asteroid, I guess, down to a very, very, very small type. But any observable asteroid is going to have an apparent size that, albeit could be very, very, very small, is much larger than the apparent size of a background star. And so, what can happen if you're really lucky, if you're really, really, really lucky, okay, you can be standing on the surface of the Earth looking at a star, and you can watch an asteroid pass in front of that star, and that is called an occultation. The asteroid um, occults a star, and sometimes you can't see the asteroid because it's too faint, right? Even if you're using a telescope, depends on the size of your telescope, depends on, again, the distance that the asteroid is, the size that the asteroid is, and in terms of brightness, it depends also on what's called what's called the albedo, the reflectance of asteroids. Most asteroids are very, very dark. They have albedos of 3%, 5%, which means, generally speaking, that the amount of light from the sun reflected off the asteroid is going to be 3, 5 percent. So darker than asphalt. Okay, black, really, really, really black. Um, so sometimes you can't see these asteroids, but what you can do is, of course, when the asteroid passes in front of the star, what's happening actually, right, is that the shadow of the asteroid is going over you, right? So it's very, very awesome, and even though the the probability is so small that you will see an asteroid occultation from your position, the thing that allows us to see these things is, one, there's a lot of asteroids, and two, there's a lot of stars. The fainter the stars go, the more stars there are, right? Also, with asteroids, the smaller the asteroid is, the more asteroids there are. And it's some kind of an exponential, it's some kind of a power law thing. Um, so, if you're able to see, a 15th magnitude star, well, that gives you a lot of possible samples. And if an asteroid just so happens to be, you know, uh, passing by, you'll see it. And what you'll see, right, is you'll see the star, and then all of a sudden it will vanish. It'll completely vanish, or at least fade, right? It'll dim for a certain amount of time, and then it will brighten back up. And if you've never seen an asteroidal occultation, it is something that you should definitely see. It's a lot. I mean, it literally is a solar eclipse. It's a solar eclipse. That's all an eclipse is just a occultation of, like, our sun by the moon, right? It's an eclipse. So asteroidal occultations are solar eclipses. So it's not, it's not quite as the wow factor as a solar eclipse, an actual solar eclipse by the moon, but it is definitely very awesome to see this. And from any location on Earth, get this, okay? These things are um, the probability of seeing an occultation from any point on Earth is very, very small, right? Very small. But as I said, because there's so many asteroids and so many stars, it turns out that from any location on Earth, you will be pretty much guaranteed to see at least one or two or three every single year, at least. Sometimes I would say, more like maybe one a month or so. So that's not bad. That's not bad. And if you're willing to travel a little bit, 100, 200 kilometers radius or so, you increase your chances of seeing an occultation by a huge factor, at least a factor of 2, if not more. So they're very, very awesome. Um, if you want, you can actually make a formal observation of this occultation. You'll need to specify your location on the planet, and you'll have to do some timing, right? You'll have to be able to specify when the occultation begins and when the occultation ends. So you'll have to figure out how you're going to do that. Um, a lot of people use video cameras, and they inject a little timestamp onto the video. So then they just, a couple of minutes before the occultation is supposed to happen, they press the record button, let it run, let the occultation happen, and then afterwards they can go back and look and see what time the occultation started. That is when the star dimmed and when the star reappeared. Now, the way that I do it, since I don't, I mean, I've got a video system now, and I've got a telescope now, and I actually want to try that kind of thing, at least eventually. I'm limited with magnitude. I can probably, I don't know, I'm going to have to find out what my limiting magnitude of my video camera is. Hello, Space TV. Nice to see you today. Hope everything's well. You may have seen an occultation of the star by the ISS. Yeah. That's sort of almost a reverse occultation, because the ISS is so bright, right? So you'll those are a little bit harder to sort of get good timing on. I got to sneeze again. Whew. Excuse me. Yeah. Occultations of stars by satellites happens as well. Those timings, though, because the satellites are moving so fast, those things last, fractions of a second. Most asteroidal occultations, will last, ones at least that you can see will last, half a second to, 10 or 20 seconds or so, depending again on the apparent size of the asteroid. So anyway, there's a couple of sites, and as I said, you can actually record these and send in your observations to these official sources and things, and I'll try to remember to put a link in the description below and on my Discord server as to where that kind of info is. I'm not gonna try to grab it now, but let's just look and see what kind of asteroids are doing some occultations. Since Space TV is on, let's see if there are any interesting occultations over in their neck of the woods over there in I think you're in the UK, right? Somewhere over there. So UK, Europe, that kind of place. So this is a site called asteroidoccultation.com, and these are up to date occultations that are taking place somewhere on the planet. Oh, here comes a kitty. Hello, kitty. Are you going to plant yourself? Yeah, planting. Good. So let's let's take a look at a few of these. Here's one. Let's see. Yeah, these are in UT time. So at 21:42 UT on the 15th of April, which is technically speaking today already. Although I'm 7 hours behind UT. So technically speaking, I'm still on the 14th of April over here. But let's just see. This one says it's going through Europe. So let's just click on this and see where that's taking place. Okay, it looks like it's going through Portugal and Spain and that one. I'm terrible. Oh, that is the Mediterranean Sea. Yeah. Duh. Okay. Um, but cool. It's going over the Mediterranean. I think that's Cyprus there. Isn't that Cyprus and Greece? And yeah, so not a great visibility one. Let's keep looking here. See if there's any other interesting ones coming up. South America, Africa. Here's another European one on the 19th of April. Oh, it's the same kind of situation. That's ridiculous. Let's see if we can find a good one here. All right, that's kind of an interesting one. So this one's taking place at 0 hours 12 minutes or so. 012. 012 to 034. Okay, I see. Anyway, so look, this is going right over Italy. It's going over the UK. It's going over the UK at 0 hours. See, here's 30, 31, 32, 33. So at 0 hours, 33 minutes, asteroid Electra is going to be occulting this star on April 21st. April 21st. So let's see, the magnitude of the star is 11.6. So that's viewable with a 8-inch scope, a 10-inch scope. So you'll be able to see this for sure. There's a magnitude drop of 1.6 magnitude. So yeah, I mean, it's basically going to vanish, right? And the duration could be up to 20 and a half seconds. So that's pretty amazing. The magnitude of this asteroid is 12.9. So, if you're looking with a 8-inch or a 10-inch, maybe even a 12-inch, you might see this asteroid. Maybe that's getting pretty faint. If you're using naked eye type of thing. So that's an interesting one. That one, let's. There's another site that I like to go to. Now that we know this information, okay, it's Electra on the 21st of April. There's another website called pointsource.com, and they have Google Maps. There's Electra. So you can click on Google Map and you can actually see exactly where that path is. And you can zoom in, right? You can zoom in here. And look at that. It's the green lines is like the edge, right? Is like the edge of the asteroid. So this guy is going to be occulting the UK just south of London, just south of Oxford, it looks like. Let's see. Let's zoom in a little bit more here. There we go. So this is where the projected path of the asteroid is going. A place called Swindon, Brighton, Reading, Dublin. Dublin looks like it's going to be really close, right? Very cool. Very cool. So, yeah, maybe, you want to get up at midnight 31 and go outside, set your scope up, and go watch this occultation. It's a big asteroid. It's a big asteroid, so the apparent size uh, uh, um, uh, is going to make for a very long, long occultation. So, Space TV, check it out. If you've never seen an asteroidal occultation, we just sort of happened to stumble upon this one that's happening in just a few days, in 6 days. So check that out. Love to hear if you actually observe it, and what scope you used, and what you thought of the whole thing. So yeah, check it out. Check it out. So let's go back to this one. The other thing that this site does is it not only gives you sort of a general idea of the path, but it also gives you finder charts, so you can find the star. So you start with a nice wide field, right? A nice wide field like this. This is what is this constellation? Trying to figure out where we're looking here. I'm a little confused. Where are we? 1 hour and 0 degrees. Yeah, I'm a little confused about where 4665. That's in Ophiuchus. I think we're looking in Ophiuchus. I think this is Ophiuchus, if I remember right. It's hard to, I can't really tell where anything is. But I think this is Ophiuchus, if I remember right. There's M10 and M12. So yeah, I think this is Ophiuchus. This is just, Libra. Libra is down here, it says. Here's LIB. Yep, there's Libra. Ophiuchus. Yeah, OPH. So anyway, so here's a nice wide field of view, so you can sort of get your bearings, right, in the sky. And then they have uh, zoomed in a little bit more, right? And then the next field of view is going to be inside of this box. So let's go to the next one. So this is a 5-degree field of view. This is sort of a field of view that you would see in like a finder scope on your telescope. 2-degree field of view, you're starting to see, you're looking through your scope, and you look at it, you still can't see the star, although it's marked there. Whoop, let's go one more. 30 arc minute field of view. You can just barely see that. So, this is what you're going to be seeing in your telescope. You're going to be seeing some of these stars. You should be seeing all of these stars. If you can't see all of these stars, then you're not going to see your target star either, because it's extremely faint. Extremely faint. So that's sort of the only the only downside to this. A 70 millimeter Celestron Exploroscope, nope, you're not going to see this guy. That star is too faint. Bummer. Yeah, you'll need at least like an 8-inch or a 10-inch telescope to see this one, and even that's going to be a little bit tough. So yeah, you need some aperture. 70 millimeters. Nope, not a chance. Sorry. But the cool thing is, as I said, is that these occultations happen all the time. Let's see. Here's another one that says it's in Europe. Let's see. Okay, it's in Eastern Europe. Here's another Europe Africa one. Let's see what this one is. Okay, that's also Eastern Europe. Bummer. There's a program that's called Occult 4, OCCULT 4. It's a program that runs on Windows, and you, you have to set it up. You have to download a bunch of files. It's not the easiest thing to set up, but once you set it up, it'll actually predict occultations for your location of any asteroid. It's got a database of like 7,000 asteroids, and then you can upload your own as well. And so that's a program that can run on your machine, and it can be specific for your location. These are very, very general, right? Very, very general. Um, so it's hard to know where they're going to be until you actually look at the paths. Right, here's another one. Yeah, that's not going to be anything for you. So yeah, this is sort of the hard way. The point here is that these things are happening all the time. There's a lot of action up there in the sky. So don't let anybody um, tell you that nothing happens. There is so much activity going on in the sky. It's just like everything else. We're just not aware of it, right? We're just not aware, but we're getting more aware. We're getting more sensitive to those kinds of things. So cheers. Yeah, you've got to be able to see an 11.9 magnitude star. Space TV. So yeah, you'd have to get out where it's dark, and you need a pretty decent size scope in order to see a star that faint, because you got to be able to see the star, right? I mean, if you can't see the star, then you're not going to see the occultation. That's why it's a little bit more exciting when it's a bright star. Um, here's one here that's magnitude 7.8 in Western United States. Let's just see how close this gets to me. Well, looking pretty close. Oh, okay, it's over in California. I'm down here in southeastern Arizona. I'm over here. So this is, yeah, this is going up the west coast of the United States. But that's occulting a pretty bright star, right? Magnitude 7.8. It's almost visible, almost. But you can sort of see, here's an 8.3 magnitude. Here's a 12.3. That's very faint. Um, there are going to be more faint stars um, occulted because there are more faint stars. That's how that equation works. There's less bright stars, of course, so there are not going to be as many bright stars occulted. Makes logical sense. Here's a magnitude 8.81, South America twilight, it says. So that's extra challenging. Okay, yeah, yeah. Yeah, extra challenging because you got to deal with twilight, which is worse than light pollution. All right, well, cool. I just wanted to show those again. I think I showed this a couple, well, several weeks ago, and I like to come back to things from time to time to remind folks who watch us on the regular, or anybody new who is watching this for the first time, that these kinds of resources exist. You don't have to uh, you know not know what's going on. So a site like Asteroid Occultation and Point Source um, is are great resources if you're into observing occultations of asteroids. And there are organizations that do this. So if you want to get heavily involved, you can actually join a group and become a contributor and the whole thing. And again, that's you're basically just collecting data, um, unless you want to take that data and run it through the scientific process. Then you're doing citizen science, right? Otherwise, you're just a data collector, which is awesome, which is very very awesome. We need data, we need data. So yeah, if you're interested in those kinds of things, get involved. Um, it's a very very active um, 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 organization, and I think there's actually several. So yeah, look around. I'll I'll poke around. I'll see if I can find some links to some of them, and I'll put them down in the description. So all right, I think I think for now it is time. Let's see. Yeah, yeah, yeah. See, it is time. The mothership is calling. So I think I'm going to get out of here for now. Hope everybody has a great evening and a great day tomorrow. I will see you again in just a little bit more than 23 hours from now. Just more or less one spin around. So don't get dizzy. Hold on to your hats. It's a pretty smooth ride. We, you know, we've all done it at least a few hundred times, so we're used to it by now. So I will see you on the spin. As I said, have a great evening, a great day. See if you can look at some asteroid occultations. They're very cool. They're very cool. Something happening out there. All right. Take care, and I will see you again tomorrow, 2 hours UTC. Thumbs up, thumbs down, whatever you want. See you later. Bye.